So for this Deltamath assignment, we're starting with identifying trig ratios. I just clicked that. And then you can see this problem. I'm going to screenshot it so I can write. Okay, in triangle BCD, let me draw that out. It's a right triangle. So I'm just going to draw some generic right triangle. Here's my right angle. They tell me that angle D is 90 degrees, so that's the one that I'm going to put at the corner with the right angle in it. Then the other two letters can go wherever. So I'm just going to put B and C like that. Okay, so let's label the rest of the stuff. CB is 37, so that would be this side, the hypotenuse. BD is 12, that would be this side. And DC is 35, that's over here. What is the value of sine of B to the nearest hundredth? So we want sine. Oops, there we go. We want sine. So let's remember SOHCAHTOA. I'm going to write SOHCAHTOA out here. Which one do you think will have to do with sine? Do you think it's S for SO, C for ka, or T for toa? You guys can say it out loud or type it in. Is it the SO, is it the ka, or the toa?
It's
So, yes, because we were dealing with sine. Sine starts with S. So also starts with S. So the S stands for sine. What does the O stand for in SO?
opposite.
Thank you. And then what does the H stand for in SO?
Hypothesis. I don't know how.
Hypotenuse. Yeah, it's okay.
Yeah.
Hypotenuse. Good. So let's take a look at figuring that out. So we have B as our reference angle. That's this one. We want the opposite side. So you have to draw the arrow directly across. And so what is our opposite side?
37.
Oh wait, opposite of the angle B. Where does our red arrow point?
35.
35, good. And the hypotenuse is directly across from the right angle and also known as the longest side of the triangle. So what is our hypotenuse?
37.
Thank you. 37. So they say, what is the value of sine of B to the nearest hundredth? That means they want us to give a decimal answer. So we're going to type 35 over 37 in the calculator and round it to the nearest hundredth. So let me do that. 35 divided by 37, and I get 0.9459459. We're going to round it to the nearest hundredths. That means we want two decimal places. So that means we have to look at the first three. And I see that the last one is a 5, which means we're going to round up. So 0.95 is our answer. Are there any questions? All right, remember you can always tell me if you have a question, even if you feel like you're interrupting, you are not, because I want to hear your questions, okay? So 0.95, but no one's saying anything, so I'm gonna go enter it in. This section, we've already done homeworks on it before, so I'm gonna think that this section's okay. The newer section is using trig to find a size. So I'm gonna do several examples from this section so that you guys can apply the notes that we just learned today. So luckily for us, they already draw a triangle for us. In triangle OPQ, the measure of angle Q is 90 degrees, the measure of angle P is 28 degrees, and OP is 92 feet. Find the length of PQ to the nearest tenth of a foot, and they already put an X there for us. How nice. So we have our reference angle right here, and we know that they gave us an X and they gave us a 92. So this 92, is that going to be the opposite hypotenuse or the adjacent?
Adjacent.
Close. It is touching the 28 degrees, but it's also the side that's directly across from the right angle. So what is that side when it's directly across from the right angle?
The hypotenuse?
Yes, hypotenuse. Hypotenuse. So 92 is actually our hypotenuse because it's the one that's directly across from the right angle. And then we also have the side X, which is touching the 28 degrees because literally like this is one of the sides that touches the angle that we were talking about. So when it is next to it, it is the adjacent. So we have the adjacent and the hypotenuse. Out of TOA, which one deals with adjacent and hypotenuse? Is it is it ka, or is it TOA?
Ka.
Ka, yes. So ka stands for cosine, C for cosine. So let's write it out. Cosine of P is equal to the adjacent, which we have as X, over the hypotenuse, which we have as 92. Does anybody have a question on how we got to here? Okay, so then X is being divided by 92. How do you get rid of dividing by 92? Oh, sorry. What am I doing? Oh, P isn't even labeled yet, my bad. Cosine of 28 because angle P is 28 degrees. Sorry, I should have put that in. Cosine of 28 degrees is equal to X over 92. Why is that looking so messy? Let's rewrite that. There we go. So like I was trying to say earlier, X is being divided by 92. How do you get rid of dividing? Opposite of dividing.
Multiply.
Multiply by 92, multiply by 92. And so what I'm going to type in the calculator is 92 cosine of 28 degrees, and that's going to give me X. So I'm literally going to type this into the calculator. So I'm going to type that into Deltamath's calculator, but before I do that, are there any questions about how I got to this point? Alrighty, I'm going to type it in then. So get that calculator up, and then I want to type in 92 cosine of 28. And so they give me 81.23. Deltamath's question says the nearest tenth of a foot. That means we want one decimal place, which means we look at two decimals. So I see 81.23. 3 is a pretty small number, so it's just 81.2. Are there any questions on that? If not, I'm going to submit it. So let's submit. Cool. Let's do several more of these. And of course, if you guys already feel like you get it and you don't have to pay attention to the notes, you can just be working on your own. But for those of you who still want more examples, that's what these notes are for. That's what I'm here for. So let me screenshot this. And we are dealing with triangle WXY. The measure of angle Y is 90 degrees. The measure of angle W is 60 degrees. And YW is 40 feet. Find the length of WX to the nearest tenth of a foot. So here is our reference angle. And so let's first figure out, what is this X? Is that the opposite, adjacent, or the hypotenuse? It's directly across from the right angle. What is this?
Opposite.
Opposite of the right angle. That makes it the what starts with H?
Hypothesis.
Yeah, hypotenuse. Yes. Hypotenuse. Remember, the hypotenuse is always across from the right angle. So if you see the one that's across from the right angle, automatically it's the hypotenuse. And then what's right next to our 60 degrees is the other side that we are given. And it's touching it, so what is the 40? Adjacent or opposite?
Adjacent.
Yes. Okay, so then once again, refer to so, ka, toa. Which one uses adjacent and hypotenuse?
Ka.
Ka, good. Ka stands for cosine because it's C for cosine. So cosine of W is equal to the adjacent over the hypotenuse. And so let's plug it in. Cosine of the W, which was 60 degrees, they just told us, was equal to the adjacent, we said was 40, over the hypotenuse, which we said was X. So, any questions up till here?
No.
All right. Then let's do the switchy thing where we switch the denominator with the thing on the other side. So we're going to switch out the x and the cosine 60. So we get x is equal to 40 over cosine of 60 degrees. And this is what we're going to be typing in our calculator. Before I type it in the calculator, are there any questions on what we just did? We just switched those two. Okay. 40 over cosine 60. I'm going to go type that in. Get my calculator up. 40 over cosine 60. It gives me 80. So we don't even need to round this time because it's just a flat 80. 80. Any questions? All right, submitting answer. Let's do some more together. Screenshot that. Okay, the reference angle they gave us is right over here. Dang, why? They keep giving me the same like adjacent and hypotenuse, but whatever. Okay, 19 is directly across from the right angle. What side is always directly across from the right angle?
Hypotenuse.
Yes. And what side is right next to our reference angle? What is x?
Adjacent.
Uh-huh. I don't know why they keep giving us adjacent and hypotenuse, but maybe I'll find another example soon. Okay, so once again, so, ka, toa, which one uses adjacent and hypotenuse?
Ka.
Ka, which is cosine. So cosine of E is equal to adjacent over hypotenuse. And so then cosine of 63 degrees is equal to our adjacent side was x and our hypotenuse was 19. Then x is being divided by 19. To get rid of that, we just multiply by 19 on both sides. That cancels that out. You get 19 cosine 63 degrees is equal to x, and that's what we're going to type on our calculator in just a moment. But before we type it in, are there any questions? All right, 19 cosine 63. Let's type that in here. That gives me 8.625. We want it to the nearest tenth of a foot, which means we're going to look at the two decimal places. So 8.62, 2 is a tiny number, so we're just going to keep it at 8.6. Any questions? Okay. I'm going to try to see if we can get one that's not cosine. And I'm just going to do that by giving up on a bunch of them. Okay, finally, here's one that's not a cosine. Okay, so I'll leave this one as one of our final examples. So we are given this as our reference angle. And then let's figure it out. What is the side that's directly across from our reference angle?
$7.9.
Yes, but what would that be? Opposite, adjacent, or hypotenuse? Across from our reference angle.
Opposite.
Opposite, yes. And then what about the one that's right next to our reference angle?
Adjacent.
Adjacent. Cool. So we got opposite and adjacent. Let's take a look. So Ka and Toa, which one uses opposite and adjacent?
Toa.
Toa, yes. And the T in Toa stands for tangent. So we have tangent of the angle F is equal to opposite over adjacent. And so let's write it out, or let's plug it in. Tangent F is 53 degrees is equal to the opposite side, which we said was 7.9. That's really ugly, but it's okay. Over the adjacent, which is X. And so we have X in our denominator. We're going to switch it with the other side. So we're going to switch out those two, which means we get X is equal to 7.9 over tangent of 53 degrees. So the way we got X by itself was we switched the denominator with the other side, because you can do that. Are there any questions on this one before I go type it in? Okay, so I'm going to go type it in. And we got X is 7.9 over tangent 53. Okay, that's not 7.9, that's 79. Give me a second. There we go, 7.9 over tangent 53. And then we want it to the nearest tenth of a foot. So we look at two numbers, 5.95. So that last 5 is pretty big, which means we need to round up the 9. So instead of 5.95, it's going to be 6.0. Are there any questions on this one? Okay. So we did 4 examples of these. I hope that's enough. If it's not, we can you can call me over during the breakout rooms and I'll help you out there, okay? So yeah, even though we didn't do a so for sine, it's the same process. If you find out that you are given an opposite and a hypotenuse, then that means you're just going to use sine. But the process of solving it is the same thing, and I'm confident that you guys can get it. So I'm going to stop the recording here.